You might want to remember these dates. No, seriously, don't just hear them, remember them. Because right now, everything feels still. The night sky looks calm, frozen, peaceful. But that's a lie. At this exact moment, something the size of a skyscraper is racing silently toward Earth. Somewhere out there, a dead star is seconds away from detonating. And our moon? It almost didn't make it through this decade. And the strangest part? You're going to see some of this happen with your own eyes. If you look up at the constellation Corona Borealis sometime soon, you might notice something unusual. A bright star that wasn't there before. It'll look harmless, just another quiet dot. But what you're actually seeing is an explosion. In a system called T Coronae Borealis, a dense white dwarf has been slowly stealing gas from a nearby red giant for decades, quietly, patiently, building pressure, until it couldn't anymore. Then, everything ignites. A thermonuclear explosion so violent it creates a glowing shell of plasma millions of degrees hot. And here's the part that should bother you. This didn't just happen.
It happened 3,000 years ago. That light is only reaching you now. You're not watching the present. You're watching a ghost. Now mark this date, August 2nd, 2027, because on that day, the sun will disappear. Not partially, not briefly, completely. For 6 minutes and 23 seconds, the world will go dark in the middle of the day. This will be the longest total solar eclipse of the century. And the alignment behind it is almost unsettling. The moon will be closer than usual, bigger, heavier in the sky. The Earth will be farther from the sun, making it appear smaller. And just like that, our star is gone. A shadow nearly 300 kilometers wide will tear across the planet at over 2,500 kilometers per hour. You won't outrun it, not even in a jet. Cities will dim, temperatures will drop, animals will go silent. And then, just as suddenly, the light comes back, like nothing ever happened. Now, here's where things get uncomfortable. April 13th, 2029, an asteroid called Apophis, about the size of the Empire State Building, will pass incredibly close to Earth. For a while, scientists weren't even sure if it would hit. If it did, it wouldn't just be damage, it would erase an entire region. But it won't hit. It'll miss. Barely. Just 32,000 kilometers away, closer than many of the satellites orbiting Earth right now.
Close enough that you'll be able to see it moving across the sky, not as a blur, but as a dot sliding through the darkness in real time. And as it passes, something even stranger happens. Earth starts pulling on it, hard. The side closer to our planet feels a stronger force than the far side. The result? Internal stress, fractures, surface shifts, asteroid quakes. For a brief moment, Earth becomes the aggressor. Now here's something we almost got to witness, and honestly, it's a bit disappointing that we won't. In 2032, an asteroid roughly 60 meters wide had a real chance of slamming into the moon. No atmosphere to slow it down, no resistance, just impact. The explosion would have been hundreds of times more powerful than Hiroshima, visible from Earth as a sudden flash, followed by a cloud of debris rising off the lunar surface. But it's not happening. New calculations show it'll miss by just 21,000 kilometers. Cosmically speaking, that's nothing. We almost watched the moon get hit in real time. Now, imagine this instead. It's August 2050. You step outside at night, look up, and Mars isn't just a dot anymore. It's a world, a glowing red sphere hanging in the sky, close enough that even a cheap telescope reveals its ice caps, its dust storms, its surface. Not distant, not abstract, but real, uncomfortably real. Then, in 2061, something returns that humanity has been watching for centuries. Halley's Comet. Not famous because it's the biggest or the brightest, but because it changed how we think. There was a time when comets were seen as omens, signs of disaster, until one astronomer realized something strange. It wasn't many comets appearing randomly. It was the same one coming back again and again on a schedule. In 2061, it returns, and this time we get the perfect view, a long, glowing tail stretching across the sky.
But what you're really seeing is something dying. A frozen object boiling in the vacuum of space, shedding millions of tons of material as it passes the sun, then disappearing again into the dark, waiting for its next return. Now fast forward to 2083. A new star suddenly appears in the sky, bright, impossible to ignore. But it's not being born. It's the result of two stars colliding. A white dwarf and its companion, locked in a slow death spiral, finally merge. The result is a thermonuclear explosion so powerful it will outshine almost everything in the night sky. For weeks, the sky will look different. Then it fades, like it was never there. And then comes something even stranger. In 2092, Jupiter's 4 largest moons will disappear. Not explode, not drift away, just vanish. Io, Europa, Ganymede, Callisto, all gone. Because for a few hours, everything aligns perfectly. Some pass in front of Jupiter and blend into its clouds. Others slip behind it into shadow. Some eclipse each other. From Earth, they collapse into a single point, a perfect illusion. So precise, it almost feels intentional. And here's the truth that ties all of this together. The sky isn't still. It only looks that way. In reality, it's a timeline. Events are constantly unfolding, some happening right now, others already finished long ago, their light only just arriving. When you look up, you're not always seeing the present. Sometimes, you're looking at something that ended thousands of years ago. And other times, you're watching something that's just about to begin.